We're doing finite and infinite sets, just some set notation, membership in a set, and rearranging before graphing. So you guys have been working on solvings for a certain variable. Now we're going to do that, and we're going to graph. So what we're going to do is we're going to start by solving for y, and then we're going to graph it. That's two things you guys 100% know how to do. We're just going to put them together. All right. So this is some set stuff. So a finite set is bounded or limited, and an infinite set is unbounded or without limit. Guys want to put that in your notes. That's just some vocab. And then we're going to look at some examples. Do we think that the set R, this is set notation, we have usually a capital letter, which is the name of the set, equals, and then we have the squiggly brackets and the numbers inside. So we did a little bit of this with the different types of numbers, like natural numbers, counting numbers, integers. All of those are sets. So do we think R is finite or infinite set? Andrew? Finite, yeah. There's only 4 numbers in there. They're all contained. It's bounded and it's limited. There's not a bunch of numbers in there. So this set right here is finite. So that leaves Q being infinite, right? Because it has ... This one is infinite. It's going to go on forever. That's what that ... means. So 4, 5, 6, 7. It's going to keep going, counting along with the pattern. So 4, 5, 6, 7, 8, 9, 10, blah, 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 forever and ever. The ... means it's infinite. It has an infinite amount of numbers inside of the set. So those are just 2 types of sets. Pretty easy to remember, right? Infinite, you guys know, is very large. So infinite is just going to keep on going on forever. All right, membership in a set. Represent the following numbers as being members of a set K. So there's a few important things when we want to use set notation. So we know we need the curly brackets. We know we're going to have a capital letter equals. We also want, so we're going to have K equals. Bloop, bloop. That looks actually cool with the fancy pen. So we always want to put, you guys might want to make note of this. First, we always want to put our numbers in order. And second, we only want to include the numbers once. So we want to represent the following numbers as being part of the set K. And we have 3, 1, 0, 5, 0, 9, 5. So I see 0 appears twice, 5 also appears twice. But when I write them in set notation, I'm only going to put those numbers in there one time. They're not going to come in there twice. So we're going to start from the bottom. We're going to go up. So our numbers are in order. 0 is definitely my first number. So we put 0, comma. I'm just going to cross them off as I go. That counts for both of our zeros. And then we have a 1. That definitely comes next. Cross that guy off. And then I'm going to have 3, cross that one off. We have 2 5s. We're just going to write it once when we're using set notation. And then finally, we're going to have 9. This is a finite set where we don't have a ... because it just has a finite number of numbers inside of it. We close it with another squiggly bracket at the end. All right, some new symbols also. It's kind of like a weird, funky-looking round E. So when you draw it, I always just draw it by going like this and then putting a line there. So what the E without the slash in it means, let me erase this really quick. This one means is an element of. And the E with a slash through it means is not an element of. So how we can tell, it says down at the bottom, first example says 3 is an element of K. So we look in our set, 3 is in our set, so that's what that means. It basically means 3 is inside our set K. 3 is in there. 2, however, is not inside of K. If we look at our set notation, K equals, there's no 2 in there, so 2 is not an element of K. So probably a good idea to give these guys write these guys down too, and make sure you know that they are relating to this set up here, because our set K is what we wrote in set notation. So 3 is in there, and 2 is not in there, is what those mean. All right, so let's try. Given the sets, so we have these sets A, B, and C. We want to figure out if the following statements are true or false. So what I want to do with you guys, we're going to go through. I'll give you guys a second to copy these down, but what I want to do is when I say something, I want everyone to give me either a thumbs up or thumbs down. If it's thumbs up, then you think it's true. If it's thumb down, then you think it's false. So I'm going to pause this, let everyone write everything down for these ones. So 5 is an element of B, thumbs up or thumbs down. Everyone should be give me some thumbs. Lots of thumbs up. I agree. We're going to give that guy a smiley face. 5 is not an element of C. Thumbs up or thumbs down. Lots of thumbs up. This one is true. There was some cute, it's kind of like a double negative, right? So 5 is not an element of C. 5 isn't in there, which is true. Okay, so 0 is not an element of A. Lots of thumbs downs, good. 0 is not in the curly brackets for, oh, that's a double negative. That one's confusing. So that is not true because 0 is an element of A. So you got to kind of think about these. 0 is an element of A. So the statement 0 is not an element of A is false. All right, finally, 3 is not an element of C. Very good. Sad face. That one's false. So smiley faces mean true, sad faces mean false. You guys can do that on your sets if you really want to. All right. Pretty easy stuff. I think you guys can all do it. All right. Rearranging before graphing. This stuff is pretty important, you guys. You've been doing both things separately, but now we're just going to put them together. All right, so in this slide, it tells us solve for y first with lots of extra stars. This is really important. Whee! You really have to do that. It's not going to remind you to do that on a set or on a test. It's not going to say you need to solve for y first. What you guys need to remember is that whenever it says graph and we don't have just a nice y equals, we always have to solve for y before we can graph. Okay? So don't forget that. We need to get an equation first, a nice equation first, and then we can graph. First step is always to solve for y first. So you guys might want to write that down, put some stars by it. I don't know, write it in bold, capital letters. We always have to solve for y first. So we're going to start with this equation, 3x plus 2y equals 4. So if I want to solve for y, my y is right here. What should my first step be if I want to solve for y? Leah? Subtract. Yep. So first I want to get this chunk by itself. So I don't want the x piece. I'm going to subtract 3x from both sides. Subtract 3x from both sides. Whee! So I'm going to get 2y equals 4 minus 3x. Now this still doesn't really do me any good for graphing. This is not a nice equation. I need y literally all by itself, and I have 2y. So what do I have to do to both sides to get y actually by itself? Micaiah? Divide by 2. Good. This is 2 times y, so to get rid of that 2, I need to divide both sides by 2. This is where it's important, you guys, that we divide all the pieces separately, which most of you guys have been doing. So every piece needs to be divided by 2 separately. These 2's cancel. We get y equals 4 divided by 2 is 2. And then we have minus 3 over 2x. This is what we wanted. We're halfway there. Now we just have to work to graph it. So we get y equals 2 minus 3x. Leah? What'd you say? Cancel. That would require multiplying everything by 2, and then we wouldn't have a y by itself. So the x can have a fraction. We can't have anything in front of the y. Good question. Okay, so we always want just y equals at the end. Now we can go and we can make a t-table to graph. So step number 2 is to make a t-table. All right, we have a fractional coefficient. What is the best thing for me to do when I have a fractional coefficient in terms of my x values, Monica? Fractions I can cancel out. Good. So this is going to be my x. This is going to be my y. So what are my x values going to be if I want this to work out nicely? Andrew? Multiples of 2, right? So I want to center my graph around 0. And then I'm going to go by 2. So I'm going to have a -2, -4, and then I'm going to have 2, and then I'm going to have 4. So this is just like we had a separate lesson that was all about graphing. And we decided whenever we have a fractional coefficient in front of x, that means there's just a fraction in front of x, we always want to pick our x values to be multiples of that number. So this is a 2. We want to have multiples of 2. So 0, -2, -4, and then +2, +4. So now I'm going to go through and I'm going to plug in all these values. So I'm going to have 2 minus 3 over 2 times -4. All right, so I'm going to have, this is going to cancel. This is going to become a 2. So I'm going to have 2 minus 3 times -2 is going to end up being 2 plus 6, because I have a double negative there. So that's going to be 8. So my ordered pair is going to be -4, comma 8, x, comma y. Now I'm going to do the same thing with -2. So 2 minus 3 over 2 times -2. This time my 2's are going to cancel, but I can't forget that I still have this negative on here. So this is basically like a -1 right now. So I'm going to have 2 minus 3 times -1 is really like 2 plus 3, 5. So I'm going to have -2, 5. One like this, you 100% need to show some work of plugging stuff in. All right, it's a little too weird for you to not show work. All right, so 0, 2 minus 3 over 2 times 0. That's just going to be 2, right, because this stuff is just going to go away. So I kind of start to see a pattern. I have 8, 5, 2. So I know what I should be getting for 2 and 4. This is going to be 0, 2. I'll plug in 2, 2 minus 3 halves times 2. These 2's are going to cancel. 2 minus 3 equals -1. 2 minus 3 halves times 4. This is going to become a 2 from the canceling. 2 minus 6 equals -4. So my ordered pair here is going to be 4, -4. This ordered pair was 2, -1. So now using those ordered pairs, I'm going to come up to my graph and I'm going to plot them. So my very first ordered pair was -4, 8. So I need to go left -4, so going to -4 on my x-axis. And then I'm going to go up 8, which would be somewhere up higher. That's not even on my grid. And then I have -2, 5. -2, 5 right there. What's next? 0, 2, 2, -1. And finally, 4, -4. All right, now I'm going to use a nice straight line, and I'm going to connect my points. That was not the very greatest connecting job I've ever done. Always put arrows on your lines, and then we're good to go. So this is just putting 2 steps that you guys 100% already know how to do, putting them together. We always have to solve for y first. That's the most important thing you can learn in today's lesson. Okay, one more. I'm going to give you guys maybe 3 minutes to work on this one yourselves. It's a little bit easier. So we have to solve for y first. So start for solving for y in this equation. pick some x values. And all right. Go ahead and grab a whiteboard.